Today we are diving into an essential topic for anyone working with virtual machines, networking modes in hypervisor. Whether you are setting up a lab for cybersecurity, testing malware safety, or just experimenting with virtualization, understanding how VMs communicate with each other and the outside world is critical. In this video, I will break down different networking modes, how they work and when to use them. First of them is Network Address Translation Mode, or known as NAT mode. Network Address Translation or NAT mode is a default network setting in most virtualization platforms like VirtualBox, VMware or hypervisor. It allows the virtual machines to access the internet while keeping it isolated from other machines on the network. Let us break down how it works and when to use it. In this scenario, we will take an example of a dummy lab setup where there is internet connection to a physical router where a physical PC just like our laptop is connected. Now, our physical PC has a physical host which is a hypervisor software just like a Oracle VirtualBox or VMware running on it. On that we have made two VMs, VM1 and VM2. Both these VMs are assigned an IP address which is of a private IP address range which is different from our main host network as provided by the physical router. In NAT mode, the VM is assigned a private IP address and all outgoing traffic is routed through the host machine, which acts as a middleman between them. The VM can access the internet just like a regular device. It can communicate with the host in one-way manner, meaning the VM can initiate the communication with the host, but the host cannot directly connect back to the VM. Other physical machines on the network cannot see or access the VM. This setup makes a NAT an ideal for general VM usage, safe browsing, and situations where you need internet access without exposing the VM to the network. But NAT has some limitations also. VMs using NAT mode cannot communicate with each other because VM gets only its own private IP address behind the host. It is not ideal for running network services like web servers because the external devices cannot directly connect to them. That is why all the major protocols which may run on web services are not visible from the outside network. So VM gets IP address from virtual DHCP server, no communication between the VMs. Overall, NAT is a great choice when you need internet access but want to keep the VM hidden from the rest of the network. The second networking mode is bridge networking mode. Unlike NAT mode, which isolates the VM, bridge networking connects the VM directly to the physical network. This allows the VM to act like just like a normal device on the network, just like a physical computer. Here also we will take the example of a dummy virtual lab. Here the internet access is provided to the physical router to which our physical PC or laptop is connected. On this physical PC, we are running a physical host which may be a Oracle VirtualBox or hypervisor solution. On that we have made two VMs, VM1 and VM2. Here you can see that the IP address assigned to the virtual machines are from the same network as of the host network and other physical devices on the network. It can communicate freely with the host, other VMs and other physical machines on the network. Internet access is available because the VM is directly connected to the router or the network gateway. This makes bridged mode ideal for network testing, running servers, situations where VM needs to be treated as a real machine on the network. Bridged mode is commonly used in testing network applications such as web servers, file sharing servers, simulating real-world environments for cybersecurity testing, allowing VMs to interact with each other and other devices on the network just like physical machine. However, bridged mode comes with some risk. VM is fully exposed to the network, meaning it is vulnerable to attacks. Malicious software inside the bridged VM can spread to the host and other network devices. It may require additional configurations in the corporate networks where DHCP is restricted to limited IP address. Here, internet access is provided to all VMs. VMs can communicate to each other and VMs get IP address from the physical router of the device. If you need your VM to behave like a regular device on a network, bridged mode is the best option. But if security is a concern and you want to use internet also, then NAT mode is the ideal choice for you. The third network configuration which we will discuss here is host-only network. Host-only network is an isolated network mode that allows communication between the VMs and the host as well as between the VMs, but completely blocks the internet and physical network access. It is ideal for secure private lab setups. Here also we will take an example of a dummy lab setup where internet is provided to the physical router and to which a physical PC is connected. Here we are using a hypervisor or like Oracle VirtualBox or VMware, to which two VMs have been made, VM1 and VM2. Here you can see that both the VMs and the physical host hypervisor have been assigned a different private IP address which is different from the IP address range of our network. The VM can communicate to the host system, which is our Oracle VirtualBox system. Multiple VMs using the host only mode can talk with each other as if they were on the private network. The VM cannot access the internet or physical network. Everything stays contained inside the setup. This is preferred for malware analysis, private lab environments, and security testing, where you don't want the VM to have any outside exposure. Host-only networking is best suited for malware analysis, private network testing, secure development environments for testing applications in isolated space. However, it also has some drawbacks, like there is no internet access to these VMs, meaning you cannot download updates or external tools without switching the network modes. Cannot communicate with the physical machines in the outside network, which limits its external integrations. Host-only networking is a great option when security and isolation are the top priority, especially in malware analysis and penetration testing environments. Now that we have covered NAT, bridged and host-only modes, let us compare all the major networking modes and their best use cases. Each mode serves a different purpose depending upon whether you need internet access, isolation or full network integration. As you can see in the table, I have divided it into various categories depending upon the access to other VMs, access to host, access to physical machines and internet access. As discussed, the NAT mode is generally used for safe browsing, general VM usage, internet access without exposing the VM to the network. Whereas bridged network just like works as any other physical machine on your system. It works for running servers, testing network applications. Host-only network is a very private lab setup communication where the communication is allowed between the VMs, but no communication from the outside world is allowed, which keeps it secure. There is another mode available to us, which is internal mode. Here, access to other VMs is allowed, but everything other is restricted. Isolated test environments where only VM within the same network can communicate. There is another mode available in some hypervisor solutions, which is NAT network. In this, access is available to other VMs, to the host and internet, but access to the physical machine is restricted. Multiple VMs needing the internet access, which are still isolated from the physical machines, used NAT network. Choosing the right network mode depends upon your specific needs. So, which mode you like the most? Let me know in the comment section. Don't forget to like and subscribe for more such cybersecurity insights. Thank you.